Uh, Welcome to today's lesson. My name is Andrew Cobby, and today I'm going to take you through this topic known as soil composition, which has been taken from Agriculture Form 2. So before we start, let's look at success criteria. These are what students have to know after learning this topic. So first of all, students must be able to list the components of soil. They must also be able to state the layers of soil profile, state the characteristics of layers of soil profile, and also they must be able to describe how the soil profile affects crop production. Okay, so let's now look at composition of soil, or soil composition. So when talk of soil composition, it refers to various components that make up soil. So when talk of various components, mean various parts that form the soil. So these various components, we've got inorganic constituencies, then we've got organic matter, we've got soil water, soil air, as well as soil organisms. So from this pie chart, you can see that soil air, we've got 25% of soil air in the soil. Then we've got water, which is 25%. Then we've got mineral matter, which is inorganic matter. It is 45%. Then we've got organic matter, which has got 5%. Normally, inorganic matter, it is composed of sand, silt, as well as clay that forms soil texture. So let's look at inorganic constituency of the soil. So on top of inorganic constituency of soil are mineral components that come from weathering logs. So when talk of weathering logs is when the logs are breaking, they form what is known as, they produce inorganic constituencies. So these inorganic constituencies, they form a skeleton or a framework of the soil, also called mineral matter, or they form the base of the soil, that is known as the mineral matter, which consists of sand, silt, and clay, which are referred to as fractions. These particles vary in size depending on the type of rock forming the soil and how long the soil has undergone weathering processes. This will determine the soil texture. Okay, so let's now look at the importance of organic matter. So the first one is supply of nutrients necessary for plant growth. So organic matter, they supply nutrients which help the plant to grow. Second important is water holding capacity. So I've talked of clay and silt particles. These clay and silt particles, they have got a surface. They have got a high surface area and can hold more water compared to sand. So this ability to hold moisture is very important for plant growth, especially during dry periods or dry season. So another importance is soil fertility. So the presence of certain minerals and their weathering processes contribute to fertility by releasing nutrients. So organic matter, inorganic matter also help the soil to become fertile by releasing certain nutrients. Then let's look now at organic matter. So when we talk of organic matter, it is made up of decayed plant and animal matter. or the decay of plant and animal remains. They make organic matter. So this organic matter, it is an important part of the soil because it helps to bind the soil particles, thus improving soil structure. So when the soil particles are bound together, it means the soil structure is being improved. Then this organic matter also help to loosen up the soil, creating spaces in the soil which can be occupied by water and air. So organic matter also, they help to loosen the soil particles. So if the soil particles is loose, it means those spaces can be occupied by water as well as air. Then organic matter also undergoes decomposition to release humus and nutrients. So most of the times humus is dark in color. So because it is dark in color, it helps to raise the temperature. You know that black surfaces, they absorb heat, therefore they help to raise the temperature of the soil. Those are some of the importance of organic matter. So this is just a picture of soil containing humus. So it is black in color, and that black color, it helps to raise the temperature because of its color. It helps to absorb the heat as well as raising the temperature of the soil. Let's now look at an investigation to find out if soil contains organic matter. So this is an experiment to investigate if the soil contains organic matter. So in this experiment, you need to have the following materials. So the first one, you need to have soil sample, dried soil sample. Then you need to have evaporating dish. You need to have triple stand, source of heat, then weighing scale or triple beam balance. Then we have got matches as well as steering rod. So let's look at the procedure. So the procedure, the first step is to weigh the soil sample. So for example, you have weighed the soil sample, and you have found the weight to be 25 grams. That's the first procedure, weighing. Then you have to place the soil sample in the evaporating dish. Then after placing the soil sample in the evaporating dish, you need to heat the soil gently at 105 degrees Celsius and weigh up until the weight becomes constant. Record the weight, e.g., or for example, 20 grams. That's the mass of the dry soil. Okay, so we can give the dry soil letter Y. Then heat the soil strongly until it is red hot and let it cool. Weigh and record the weight. So after recording the weight, for example, you may find that it is 19 grams. That's the mass of the bent soil. It is Z. You can give the mass of the bent soil to be Z. Then let's look at how you can calculate mass and organic matter percentage. How to calculate the mass and organic matter percentage. So first of all, let the mass of dry soil be Y. So mass of dry soil, it is Y, and if you remember from the last slide, we found that the mass of dry soil is 20. Then the mass of the bent soil, which is Z, is 19. Therefore, the mass of organic matter will be Z minus Y, which is mass of the dry soil minus mass of the bent soil. So if you subtract, you find that the mass of the dry soil minus the mass of the bent soil will come to 1 gram. Then let's look at now the percentage, how to calculate the percentage of organic matter. So to calculate the percentage now, it will be Y minus Z, which is the mass of the dry soil minus the mass of the bent soil, divided by the mass of the dry soil, which is total mass, multiplied by 100. So if you substitute, it will be 20 minus 19 divided by 20 times 100. Then if you subtract 20 minus 19, which is 1, the mass now of organic matter, that's the mass of organic matter, divided by 20, which is the total mass of dry soil, multiplied by 100. So if you do the calculation there, you find that the mass of organic matter, the percentage of organic matter, it will be 5%. So in conclusion, you find that organic matter is part or is a constituent of the soil. So if you remember, in the experiment, we talked of hitting the soil gently. So the aim of hitting the soil gently was to remove the remaining water or the moisture in the soil. And strongly hitting was there to burn the organic matter or to remove the organic matter in the soil. So the difference between soil gently heated and red heated soil is the loss of organic matter, hence the mass of organic matter. So let's now look at soil water or soil moisture. So soil water is very important part of soil. So the reason why soil water is important is one, soil water help to dissolve plant nutrients for easy absorption of plants. So we know about plant nutrients. So soil water, it helps to dissolve those plant nutrients so that the plants can easily absorb the plant nutrients. So water also is the raw material for photosynthesis. So for photosynthesis take place, there is a need for water. So water is very, very important. The other importance is water has got a cooling effect. So more especially during transpiration. So when the water is going into the atmosphere from the plants, it has got cooling effect. So another important is soil water is necessary for microbial activities in the soil. So those microorganisms to perform their activities, they require water. So you can say that water or moisture is very, very important. Then soil water, they create suitable conditions for seed germination. So it's one of the conditions for seed to germinate. Seed cannot germinate if there is no water. So you can see that soil water or soil moisture, very, very important in agriculture. Okay, so let's now look at forms of soil water. So normally we've got three forms of soil water. The first one is capillary water, then we've got superfluous water, then we've got hygroscopic water. So we're going to look at each and every these forms in details. So let's start by looking at capillary water. So on top of capillary water, this soil water occupies microspores. They occupy micropores or the very small pores which are found in the soil. So it is held strong, adhesive, and cohesive force. It is held by strong, adhesive, and cohesive force. So it's the water that is readily available and beneficial to plants. So this water, capillary water, is readily available and it is very beneficial to plants. They can be easily absorbed by plants. So it is very beneficial to plants. So the second one is superfluous water. So this is the soil water found in large air spaces. We call them macropores. in the soil particles. So once these spaces are saturated with water, the soil becomes waterlogged. This form of water is available for plant use. So this superfluous water is also available for plant use. And once the pores become saturated or they are full of water, whereby the plants they cannot absorb those water, that's when the soil becomes waterlogged. Then the last form of water is hygroscopic water. This form of water is found on the soil particles, or they're found in the form of a thin layer in the soil surface of soil particles, and they are held by strong forces, and this water is not available for plant use, or this water cannot be absorbed by plant use. So you can see that of the three forms of water, only hydroscopic water cannot be absorbed or is not available for plant use. So let's now look at experiment to determine soil water. So you need to have the following apparatus and materials. First one, you need to have weighing balance. You need to have sample of fresh garden soil. You need to have triple stand. Then source of heat. So our apparatus is going to look like this picture. Let's now go to the procedure. So the procedure of finding the soil water, the first one is to weigh the soil sample and record. Okay. After weighing, you put the soil sample on the evaporating dish. Let's assume that after weighing you find that it is 50 grams. Then take that 50 grams of soil, you put on evaporating dish. Then you have to heat the soil to 105 degrees Celsius. Then you have to stir the soil as you are heating. Okay, so the moment you are heating the soil, make sure that you are stirring the soil. So ensure that all the water has evaporated. So let the soil cool and weigh the heated cooled soil and record the mass. Okay, for example, the original mass was 50 grams. After heating and cooling the soil, you find that the weight now has come to 40. So take note that the soil can either be heated or air dried. So let's calculate now the mass and percentage of water in the soil. So let the mass of fresh garden soil be X. And remember, we gave an example that the fresh soil is 50 grams. So that 50 grams has been represented by X. Then let the mass of dry soil be Y. So that 40 grams after drying the soil, after evaporation, has been represented by Y. So the mass of water will be X minus Y. Okay, the fresh soil subtract the dry soil. So that difference is the water that has evaporated, which is 50 minus 40, it is 10 grams. So to find out the percentage of water in the soil, it means X minus Y, which is fresh soil minus dry soil multiplied by 100. So which is 50 minus 40 grams divided by 50 times 100. It means we're converting now to percentage, which is if you subtract is 50 minus 40, which is 10, divided by 50 times 100. After calculating, you find that the percentage of the water in the soil is 20%. So in conclusion, you can see that water is indeed part of the soil. So the amount of soil water depends on type of soil. For example, clay soil, it holds a lot of water, followed by loam soil. Then sand do not hold much water. So lastly, about this exercise for you. So you try this exercise and you can give your answers in the comment section. The first question is give any 3 components of soil. Then explain the importance of mineral matter. So you can explain 2 points there. So the other question is, what is the importance of dark color of humus in the soil? Question number 4 is explain any 3 importance of soil water. The last question is mention 3 forms of soil. So if I've got any question, you can WhatsApp us, and that's the number. And you can also visit our email, and that's the email you are seeing there. Thank you so much. We'll meet again in the next video.